In lesson 99, we're going to talk more uniform motion problems, only this time our distances are going to be unequal. So we go about these problems the same way we did with the other uniform motion problems. We want to remember our basic formula is that distance equals rate times time. And there's going to be two different people or vehicles or something like that in the problem. So we're going to have two of these equations that we need to figure out. So in the first example, it says at 8 o'clock, Achilles left camp and headed south at 20 kilometers per hour. So we know that we want to write down all the information that we know. That tells us that the rate of Achilles is 20 kilometers per hour. It says at 10 p.m., oh, these names are crazy. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? That sounds very confusing, but sometimes it helps us to draw a little diagram so we can see what's going on. So they both started off at the same spot. And they started off, well, Achilles started off at 8 p.m. And they are saying that Patroclus was ahead by 3 a.m. So they want to know what his speed. So that tells us that we can know the time of Achilles because he started at 8 p.m. and ended at 3 a.m. So 8 p.m. to 3 a.m. is 7 hours. And that's the time of Achilles equals 7 hours. It also tells us that Patroclus starts at 10 p.m. And again, they want to know, since he's ahead by 3 a.m., that's the stopping time for both of them. But he traveled then for only 5 hours, 10 p.m. to 3 a.m. So we also know the time of Patroclus is 5 hours. We don't know his speed. That's the one thing. That's another thing that we're trying to find out. And we do know something about their distance, which is what we're going to draw next. So if they start at 8 p.m., Achilles goes this far. We're just going to draw a little arrow. That's the difference of Achilles. Now Patroclus at 3 a.m. is 50 kilometers ahead. So he goes the distance of Achilles plus 50 kilometers. So that's the distance of Patroclus. He is 50 kilometers ahead of him. So the way we can write that is the distance of Achilles is equal to the distance of Patroclus minus 50 kilometers. He goes the shorter distance. So he takes the distance of this minus the 50 kilometers. And now we have a lot of information that we can try to plug into our equation. What can we say? Okay, so we know that the distance of Achilles is equal to the distance of Patroclus minus 50. We want to change these distances into rates and times for each of these. So we are going to have a basic distance of Achilles equals the rate of Achilles times the time of Achilles. That's our basic formula. Distance equals rate times time. That's the formula for Achilles. And then for Patroclus, we're going to do the same thing, only we're going to write the distance of Patroclus equals the rate of Patroclus times the time of Patroclus. Those are our basic formulas. Now we have all this information on our page, and we need to plug it into this basic formula in order to find it out. Just like in those word problems that we did, you have to get it down to an equation that has only one variable. Then you can solve it. So let's do that. We're going to substitute the rate of Achilles and the time of Achilles in for this dA because they're equal. So that's the first step. We're going to do the same thing with the distance of Patroclus. We're going to substitute this in for that. So that equals the rate of Patroclus and the time of Patroclus. And then we have to keep this minus 50. Now we can look at this, and we have a lot of this information. We know what the rate of Achilles is. It's 20. We know the time of Achilles. It's 7. We know the time of Patroclus. It's 5. And that only leaves us to find the rate of Petroclose, which is what our problem was asking for. So we can plug all that in, and then we can solve for the RP. So the rate of Achilles 20 times the time of Achilles 7 is 140. We don't know the rate of Petroclose, that's what we're trying to find out, but we do know his time is 5 hours. So we're going to multiply that by 5 and subtract 50. We're going to add 50 to each side. That gives us 190 equals the rate of Petroclose times 5. We'll divide each side by 5, which gives us 38 kilometers per hour. So the rate of Petroclose equals 38 kilometers per hour. So that's how you solve these problems. You need to write the two basic equations down for both people or things in the problem, and then write down all the other information you know, and then just plug it in until you only have one variable left to solve for.